Hello guys, this is Shyam from BreVITy. Today let's solve another problem called remove duplicates in a sorted array. So let's first understand the problem and look at how we can solve it, and then we'll look at ways to improve it and also solve a variant of the problem. So in this problem, we're given a sorted array, and elements in this array can contain duplicates. So our goal here is to remove them. The input array here contains duplicates, as you can see, and the output array contains only a single occurrence of each element. Now the simplest approach to solve this is to create another array of size n, and each time you encounter a unique element, you copy it to this. So at each position, if you compare it to the previous element and you know it's the same, then it's not a unique element, it's a duplicate. And if it's not the same, it's a unique element. So here initially we copy the first element. Now in the next position we know it's not the same, so we know it's the same as the previous one, so here we ignore it, the second position. Now 1 is not the same as the previous one, so you know it's a unique element and you copy it to the second array. Now 1 is the same as the previous one, the same goes to this. And when you reach 2, you know it's not the same as the previous one, so you copy it to the additional array here. So if you keep repeating this process, you'll end up with this final output here. So you've iterated through the input array and you have the output array here which contains only the unique elements. So because you had to iterate through the array once and only once, the time complexity here is O of n. Whereas the space complexity is also O of n because you had to create an additional data structure of size n. Here we didn't have to use the entire array. Let's say in the worst case, if all the elements of the input array are unique, then you will need to store n elements in the output array too. Now let's look at how to improve this. Here we use the two-pointer approach. So our first pointer I here iterates through the array and checks for duplicates. And our second pointer j is incremented each time you find a unique element. So this is done so as to store the unique element in the jth position. And you'll finally end up storing the output array in the input array itself. So now initially j points to the first position, meaning it's already included, and I starts from the second position. Here, the ith position element is the same as the previous one, so you ignore it. When you get to 1, it's not the same as the previous one, so it's a unique element. So you increment j here and store it in that position. Now these are the same as the previous one, so you ignore it. And when you reach 2, it's a unique element, and you increment j and you store it. So if you keep following the same approach, you'll finally end up with this. So here, from the 0 to the jth element, is our output array, and this is a part of our input array. So here, because we had to iterate through the array once, the time complexity again is O of n, but the space complexity is O of 1, because we didn't have to use any additional data structures to store the output. And also because we modify the input array to create the output array, this is called an in-place algorithm. This is a variant of the problem. So here, each element can have at most one duplicate, meaning that there can be 2 copies of each element. As you can see, the output array here contains at most 2 copies of each element. So the change you have to make to the previous approach is to maintain a count variable. This will basically maintain the occurrences of each element. So initially, when you have included 0, you set the counter to 1, and now because you encounter another occurrence of it, count is incremented to 2. So as you can see, j also is incremented here and you include it. So you basically do the incrementation of j and inclusion only when you find a unique element in the previous case. But in this case, additionally, as long as count is less than or equal to 2, meaning that there are at most 2 occurrences, you perform the same thing. And here, when you first encounter a new unique element, you set reset counter to 1, and you do the copying process here, increment j and copy it. And here, this is the second occurrence, so again you have to copy it. And when you reach third occurrence, that is the count is 3, you simply ignore it. And now that you found out a new unique element, you reset the counter to 1 and you copy it in this process. So if you keep repeating this, you'll finally end up with this output array. So the output here is again a part of the input array, and from the 0 to the jth element is our output array. The time and space complexities are the same for this problem. So that's how you extend the previous approach to solve a variant of the problem. That's it for today's video. If you have any doubts, leave it in the comments below, or you can head over to the Discord group. Thank you for watching.
We hope you have understood this problem through Shyam's explanation. And if you have any questions, you can ask us on Discord or WhatsApp. With that in mind, go to Leetcode and see if you can solve this by yourselves.